All right, hi guys. Today we are officially starting a new unit. The new unit is on exponential functions, where now you're going to start to see the variable in the exponent as opposed to the variable being in the base, like what we've been doing since Algebra 1. Now, this is actually very fitting to what's happening in the world today because we're going to talk about some exponential growth and exponential decay. When something is growing or decaying exponentially, that means it's growing at a very fast rate. So as you guys know, with what's going on with this coronavirus, it is growing at a rapid rate. More and more people are being found with cases with the coronavirus. So it is seen as an exponential growth type of function. So let's take a look at what the actual graph would look like. So here is the general function for exponential, whether it's growth versus decay. How you know it's going to be a growth is if you take a look at that b value or that base. If that base is bigger than 1, then you know it's going to be a growth. So let's take a look at the t-chart. If I take these x values and I substitute for x, if I plug in 2 for x, 2 squared would be 4. If I plug in 1 for x, 2 to the first is 2. If I plug in 0 for x, 2 to the 0 is 1. If I plug in -1 for x, now be careful, it's not going to make it negative, but it flips it and make it into a fraction. So it's going to be 1/2. If I plug in -2 for x, it is 1/4. When I graph these coordinates, -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. Now, one of the things I want you to notice about this graph is that if I kept going in the negative x direction, so -3, -4, -5, -6, it would keep getting to be a smaller and smaller fraction. So it would never become 0, ever. So we have what is known as what's called an asymptote, which you've seen before. So in this case, we have that imaginary line that is graphed as our asymptote. So now I'm going to go ahead and connect the dots. And then here is our exponential growth graph. As you can see, if you read it from left to right, it is growing in the positive x direction, and then it's growing very rapidly in the y direction. Now, domain and range. We do this a lot for all of our graphs. Domain, remember, is your x's. It could be any x value, -infinity to positive infinity. The range is always based off of where that asymptote is. Since the graph is above the asymptote, it's going to go from where the asymptote is to positive infinity. And that is your parent graph for the growth function. Now let's take a look at the decay function. The decay function, you'll see, if you take a look at that base, it's a fraction. Now, not necessarily because it's a fraction, base happens to fall in between 0 and 1. It is considered to be a decay. So you'll see the graph will go in a different direction. So for example, if I plug in these x's, if I plug in 2 for x, 1/2 to the second power is 1/4. 1/2 to the first power is 1/2. 1/2 to the 0 power is 1. 1/2 to the -1 is going to flip it and make it a 2. 1/2 to the -2 is going to make it a 4. Again, in this case, if I kept going in the positive x direction, so if I went to 3, 4, 5, the fraction. So my asymptote is still at 0, so it's not going to cross 0. And then when I graph it, so 2, 1/4, 1, 1/2, 0, 1, -1, 2, 2, 4. You will see these dots are now going in a different direction. They are now going in the downward direction. So this is what is called an exponential decay graph. Because when you read it from left to right, it is decreasing at a rapid rate. The domain and range, very similar to the growth graph. Still -infinity to positive infinity, and the range is based off of where that asymptote is located. Now let's take a look at some transformations so you can tell how the movement works and how it affects the domain or the range. Okay, so now we're going to look at some transformations. It's the same as if we were working with any different type of graph, whether it was a quadratic, a square root, now exponential growth or decay. The most important transformation is this outside number, this +1 right here. That +1 is extremely important because what it's going to do is it's going to move the whole graph up one space. So now, how does that affect the graph? It's going to affect where that asymptote is going to be. So now instead of 0, that asymptote is now going to be a +1. So I know not to cross that line. Now, another transformation that happens is this one right here. What it does is it takes that whole graph and it's going to move it left 2 spaces. Now, you can take the parent graph and calculate the xy's off of the movement, or you can start with your t-chart based off of how can I make that exponent 0? Well, I can make that exponent 0 if x is -2. And then I would just do the math. When x equals -2, -2 plus 2 makes 0. 2 to the 0 is 1, and then if I add 1 to it, I will get 2. And then I can move up from there. Now I'm going to make it a -1. If x is -1, -1 plus 2 is 1. 2 to the first is 2. Add 1, you get 3. Let's do another one. 0. If I plug in x equals 0, 0 plus 2 is 2. 2 squared is 4, plus 1 makes 5. I'm just going to do one more. If I put x to be 1, 1 plus 2 makes 3. 2 to the third makes 8. 8 plus 1 makes 9. Now I have some good points to go ahead and graph. So remember, you base it off of the origin. So -2, 2, -1, 3, 0, 5, 1, 9. It is my growth graph because my base is bigger than 1. And again, you are not going to cross that asymptote. Now, when it comes to domain and range, the domain will always be -infinity to +infinity, no matter what, because you can plug in any x value. But the range, again, is always based off of that asymptote. Since the asymptote is at 1, it's going to go from 1 to infinity. So now let's do the exact same thing, only this time it's going to be a decay graph. So again, that outside number is the most important number because that has just told you that the graph has moved down 2 spaces. So now my asymptote is now at -2. This transformation, when you subtract 1, means it went right 1. Again, the -2 means you went down. Again, the best way to do these is to come up with a value that's going to make that exponent 0. So now that exponent is going to be 0 when x is 1. 1 minus 1 is 0. 1/2 to the 0 is 1. 1 minus 2 makes -1. And then you can go on from there. Again, you may have some decimal values, which in this case you most likely will have decimal values if you kept going in the positive direction. So let's say instead of going to x being 2, let's say I went to x being 0. The reason why I want to go backwards is because I have a fraction. So if I put 0 in for x, 0 minus 1 makes -1. That negative exponent is going to make that fraction flip, which is then it's just going to become 2. And then 2 minus 2 makes 0. So again, the reason why I'm going backwards is because it's going to make that fraction flip. So now let's put in -1. If I put -1 in for x, 1/2 to the -1 minus 1 minus 2. So this would be 1/2 to the -2nd. But because it's negative exponent, it's going to flip it and make it 2 to the 2nd minus 2. 4 minus 2 is 2. So let's plot what we know. 1, negative 1, 0, 0, negative 1, 2. So you'll see we have a couple points that we can go ahead and plot. Again, I can keep going if I wanted to. If you have a graphing calculator, you're more than welcome to plug it in as well. Use your T-chart. You will get the same values. Again, domain, negative infinity to positive infinity. Range, negative 2 to infinity. So now let's take a look at some more transformations, and then you can graph some on your own. Okay, now both of these last examples have one extra transformation. The first two did not, and that is that there's a negative in front. So first of all, let's start with where that asymptote is going to be located. So again, the most important number is that positive 2. So there's my asymptote. Now you can probably take a guess as to what's going to happen based off of the way the graph actually looks. Now, this plus 3 means I'm going to move left 3. But now I have that front negative. That front negative is going to make it flip. So now instead of being above the asymptote, it is now going to be below the asymptote. I'm still going to do the same thing that I did before when it comes to the T-chart. I'm going to think about what's going to make that exponent 0, negative 3. And then I have to do the math, so you got to take your time. Negative 2 to the 0 plus 2. So always do the exponent first. 2 to the 0 is 1. Negative 1 plus 2 makes 1. Now, since the base isn't a fraction, I'm going to keep going. Keep making those numbers bigger. So now negative 2. Negative 2 to the first power plus 2. Again, do the exponent first. Negative 2 plus 2 makes 0. Keep going. Negative 2 to the second plus 2. Negative 4 plus 2, which would be negative 2. Do one more. Negative 2 to the third power plus 2. Negative 8 plus 2, which is 6. So I'm going to graph what I know. Negative 3, 1. Negative 2, 0. Negative 1, negative 2. I'm sorry, that should be negative 6. 0, negative 6. So now you'll see that this is just the reflection of the growth graph. So now it's no longer above the asymptote, it is below the asymptote. Now how does that affect our domain and range? Domain is still negative infinity to positive infinity, but now that it's below the asymptote, it's going to start with negative infinity and it's going to stop at where the asymptote is. So let's see one more example. So this one is now the reflection of the decay graph because we have a 1/2 as the base. So again, one of the most important numbers is that we know it is going to go right to, and it is also going to flip. So now in our plug in x values so that it makes that exponent 0. So I'm going to start off with 2. So I have negative 1/2 to the 0 power plus 1. Again, do the exponent first. Negative 1 plus 1 would make 0. Now, since it's a fraction, I'm going to go backwards. So now I'm going to put 1 in there. Negative 1/2 to the negative first plus 1. This piece is going to flip. So negative 2 plus 1, which makes negative 1. Do a couple more. Negative 1/2 to the negative second plus 1. It's going to flip and then square. Negative 4 plus 1 makes negative 3. Let's just do one more. Negative 1/2 to the negative third, which would make negative 8 plus 1, which makes -7. Okay, let's graph. 2, 0, 1, -1, 0, -3, -1, -7. Whoops. Again, do not cross that asymptote. And there is our exponential decay reflection graph. Again, domain, -infinity to +infinity. Range, -infinity to 1. And since it can't be 1, that's why we use the parentheses. Okay, so we're going to stop there. So your only homework is the graphing and the writing the equation piece based off of the transformation. So it's just the front of the homework. Next time, we're going to do the applications, which are the word problems. You are going to need a calculator to be able to do those because it's a lot of plugging in and getting higher numbers with decimals. So again, your only responsibility is to practice the graphing. Okay, so we'll pick up with the second piece. Next lesson.